Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syami.
My name is Karin Nasiha. My name is Nur Hanan Wahida.
And my name is Ahmad Afzal. We are from Group 4 and today we're going to talk about reversible and irreversible processes.
First thing first, what is reversible process? Reversible process are defined as those that can be reversed without leaving any trace on the surrounding. This means that both the system and its surroundings have to go back to their original state. This is possible only if the net heat and net work exchange between the system and the surroundings is zero for the combined. This restoration is made without leaving any net change on the surroundings. Whereas for irreversible processes, the surroundings usually do some work on the system and therefore does not return to their original state. Then example of reversible is constraint expansion, which is theoretically reversible with the same example of a piston cylinder system. Piston cylinder system, we can have smaller masses on top of the piston. If we take one by one, the piston will rise little by little when the number of masses approach infinity with infinitesimal masses that add up to the same original mass. From the irreversible example, we could have the position of each mass be exactly where the piston will rise up to in theory, and of course with an infinite number of masses we could just place each mass back on top of the piston, making this process completely reversible. Meanwhile, having an infinite number of masses is not possible, but what this example serves as is to show that some processes are more irreversible than others, and the closer we get to an idealized reversible process, the efficiency of that process itself is going to be higher.
Reversible processes actually do not occur in nature. They are merely idealizations of actual processes. Reversible process can be approximated by actual devices that is created in the world, but they can never actually be achieved. Now, you may be wondering, why are we bothering with such fiction things? There are two reasons. First, they are easy to analyze since a system passes through a series of equilibrium states during a reversible process. And secondly, they serve as an idealized model to which actual processes can be compared to. So there are actually two types of reversible process. One is internally reversible and second is externally reversible. So the first one, internally reversible, happens if no irreversibilities occur within the boundaries inside of the system during the process that's occurring. During an internally reversible process, a system proceeds through a series of equilibrium states, and when the process is reversed, the system passes through exactly as the way it is before. While externally reversible means no irreversibilities occur outside of the system during the process that's occurring. Heat transfer between a reservoir and a system is an externally reversible process if the outer surface of the system is at the temperature of the reservoir.
Okay, now let's move on to irreversible process. By definition, irreversible process is a process that cannot be reversed spontaneously and restore the system to its original state. This means that all of the energy dissipated during the process makes it impossible for the system to return to its initial conditions without external intervention, such as refrigeration or chemical processes.
Some example of irreversible process is heat transfer, friction, and unrestraint of gas. So the first one is friction. When the direction of the motion is reversed, the bodies are restored to their original position, but the interface does not cool and heat is not converted back to work. Instead, more of the work is converted to heat while overcoming the friction. First that also oppose the reverse motion. Since the system is It seems the system and the moving bodies and the surrounding cannot be returned to their original state. This process is irreversible. Friction does not always involve two solid bodies in contact. It is also encountered between a fluid and a solid, even between the layers of fluid moving at different velocity. Therefore, any process that involves friction is irreversible. The larger the friction force involved, the more irreversible the process is. The second one is heat transfer. Heat is transferred from the warmer room air to the cooler soda. The internal energy of the surrounding will increase by an amount equal in magnitude to the work supplied to the refrigerator. The restoration of the surrounding to the initial state can be done only by converting this excess internal energy completely to work, which is impossible to do without violating the second law, since only the system, not both the system and the surrounding, can be restored to its initial condition. Heat transfer through a finite temperature difference is an irreversible process. Heat transfer can occur only when there is a temperature difference between a system and its surrounding. Therefore, it is physically impossible to have a reversible process because of the heat transfer process become less and less irreversible as the temperature difference between the two bodies becomes zero. So the smaller the temperature difference between the two bodies, the smaller the heat transfer will be. As like Afzal said before, this process also like the same as the reversible process, which is about the unrestraint of gas. When the membrane is ruptured, the gas fills the entire tank. The only way to restore the system to its original state is to compress to its initial volume while transferring the heat from the gas until it reaches the initial temperature. From the conversion of energy consideration, it can easily be shown by the amount of heat transfer from the gas equal to the amount of work done on the gas by the surrounding. The restoration of the surrounding involves conservation of this heat completely to works, which will violate the second law. Therefore, unrestrained of expansion of gas is an irreversible process.
Some of the examples that can be related to what Hannah said before. The first question is, a cold canned drink is left in a warmer room where its temperature rises as a result of heat transfer. Is this a reversible process? Explain. The answer is no. This is an irreversible process because it involves heat transfer through a finite temperature difference. This is stated earlier, which some of the energy is lost to the surroundings during the process and the energy cannot be transferred back to the system, the canned drink, due to the second law of thermodynamics. The second question is, show that processes involving rapid chemical reactions are irreversible by considering the combustion of a natural gas, such as methane, and air mixture in a rigid container. The answer is the combustion of natural gas and air produce carbon dioxide and water and other compounds while releasing heat to the cooler surroundings. It is unlikely for the surroundings to return this energy or for the combustion products to spontaneously revert to the original gas and air mixture. This is also due to the second law of thermodynamics, which all of the heat and energy dissipated will not come back to the original system and will not turn back into the original gas that we started with.